we'll be looking at the database technology, and then we'll also be diving into demo code that uses the serverless.com framework and Amazon Lambda and integrates in the browser using front-end JavaScript. So if you're excited about JavaScript or about Lambda or serverless or a new generation of databases that offer scalable distributed consistency, then you're in the right place. So with that, I'll tell you just a little bit about myself and then a little bit about the database, and then I'll go over the agenda for the talk. So my background is I started out as a web developer writing PHP and Rails apps back in the day, and got involved in the NoSQL database movement via open source and contributing to Apache CouchDB, which I took a focus on the developer experience and kind of getting all the APIs together in a way that made them coherent so that you could use the product as, for a full range of things instead of narrow use cases. And that similar pattern, plays out in the industry over and over again. Here at Fauna, my role is about focusing, again, on that similar stuff, on packaging our APIs for usability and for developers to enjoy. So I get to write applications using our stack and find the rough edges and talk to people like you about it and get feedback and integrate it into the product. So the Q&A questions that we'll be doing later in this presentation are super valuable to me in terms of learning how to improve the product and improve how we talk about it so that people can understand it right away. So please do write down questions you have as we're going, and we'll have plenty of time at the end to take questions and talk about advanced topics. So brief introduction to FaunaDB, just so you know where we are in the universe. It's a general purpose database, and every database has its sweet spot. So the sweet spot for FaunaDB is the type of applications that you used to go to standard issue relational database for in the days before web scale. So it's got strong transactions, and instead of transactional support within the single database instance, it's transactional support on a global basis, and that's what's new in 2017. So we're part of that new movement of databases that allows you to use the database, like you may have been trained to do in a previous era, and get all those features, but also have the scalability and performance that you need in 2017. So we'll talk a lot more about that. It's also got a rich query language that has similar expressive capabilities to SQL or to the other new style query languages that you see from the new style databases. We'll talk a fair amount about how FaunaDB fits in the serverless ecosystem and how the pricing model, the deployment model, and the client interaction model all fit like a glove for serverless. But you should also know that FaunaDB is available on-premise for enterprise licensing when people's data volumes grow beyond what makes sense to do in a managed cloud. The other feature that kind of sets this apart from other databases that run at similar scale and performance is baked in from the ground up concept of hierarchical multi-tenancy with quality of service. And the point of this is to make it so that one single Fauna cluster can support heterogeneous workloads, for your entire organization or for multiple organizations, and to allow you to schedule and prioritize each individual workload within all that. So the point of having all those workloads mixed on a big cluster is that you're able to better utilize the hardware that way. We'll talk more about this later too. So some use cases that we won't talk much about today, but just to whet your appetite and get you thinking about how people are using FaunaDB. A big one that hits in the sweet spot is the distributed ledger use case. So basically, what some folks think they need a blockchain for. If you are working among trusted counterparties, then what you really need is a scalable transaction system. And the global consensus algorithm that Fauna uses makes it a great, candidate to support distributed ledger use cases. And we're talking to financial services institutions and consumer-facing brands about their payment and transaction processing infrastructure. And I think that's new. I didn't see that in the previous generation of NoSQL. So it's good to see that the market has evolved to be ready to evaluate databases for those serious system of record use cases. There's also a fair amount of social graph content services using FaunaDB for your basic social content and wanting to see, posts from my friends that have happened recently. Those queries are supported from the ground up in Fauna, and we'll see a little bit more about that temporal support later. So your, broad web API social data sites, that's going to be a great fit for the Fauna data model and the access patterns. And then we'll also talk at the very end about how you can modify the demo that I'll be giving today to connect from the browser directly to FaunaDB instead of going through API Gateway and the Lambda serverless layer. So I guess those are called single-page applications, but I also think it's fun to call it serverless. So we'll look at how you can modify this serverless application to have an even simpler stack at the very end. So here's a little more about the demo that we're actually going to look at today, and a little bit about why I chose to develop it like I did. So if you're not familiar with TodoMVC, it's a standardized package, sort of a set of implementations of the same application in every different front-end JavaScript framework. And so it provides kind of an anchor for evaluating new frameworks and deciding, what the different styles of the different frameworks look like in code on an actual application. And so I thought, if I'm going to write a demo, I better use this because it's familiar enough to people and it's close enough to the data model that we want to show. So I went digging around and trying to find, surely somebody has written TodoMVC that talks to a backend and has the user log in. But the best I could find was this quote on Reddit that says, if you decide to do a to-do list app again, please give it a backend with user auth and persistent storage using a database. So when I found that, I realized I should stop Googling because nobody had done that yet, at least not in a way that, used a standard CRUD backend and had, kind of basic interactions from the app layer. There was some stuff that did, fancy data binding or whatever. So I get to write it, and that was a lot of fun, and we get to look at it more today. So the user auth that we use, and we'll talk a lot about this, is, as far as I'm concerned, production quality, in the sense that if you're writing a production app, you could start by using it, and you might end up modifying the code as you bring your app to maturity. But it's a great start for production style authentication. So if you sit through this talk, you'll be set up to do your own Lambda authentication service and connect it to FaunaDB on the back end, or other options as well. So here's the agenda. We'll talk more about FaunaDB and specifically why it fits the serverless world like a glove, and then we'll go into that demo TodoMVC and talk about the application architecture and the code. So specifically, we'll look at the Authentication Boilerplate, which is a library in the serverless ecosystem that I encourage you to use for your early development and your production applications. There's also the serverless CRUD package that is the REST backend that the TodoMVC UI talks to. So we'll look at that for examples of how your backend queries the database. And then kind of the common thread that runs through all this that is what makes the demo somewhat advanced in production style instead of just a toy is that we're using FaunaDB's object level access control throughout. So you'll be able to see how you can thread authentication tokens for your users all the way through to the database and have the user act on the database with only their permissions rather than having the security policy have to be encoded in your Lambda functions. And at the end, we'll do a demo and take questions and maybe get into some advanced topics. So FaunaDB, we say, is the first serverless database. And before we get into what sets it apart, we'll talk about what it has in common, what it means to be a serverless database. And obviously, that means it runs in the cloud and everywhere in the world, and you don't have you don't have server problems. You have service provider problems, I suppose. But that's the service provider's responsibility, and we're seeing that even medium and large enterprises are starting to see that running a database in a managed cloud can be lower risk than running it themselves. So you'll also see in the serverless ecosystem, you want to have these JSON-style NoSQL objects and schema support. So Fauna lets you store the data as it comes to you. It doesn't make you flatten it into tables. But it does allow you to tag certain fields and subfields as relations, as references between objects. And so with those objects tagged using the references, you're able to do foreign keys, you're able to do uniqueness constraints and joins, and a lot of the features that you were used to in the old relational database days, you can do that again. I guess for me this is kind of coming full circle because the original NoSQL movement was about throwing out database features in order to get performance and scale, and now we're able to bring those features back and maintain that performance and scale, and it's really opening up the market. There's a lot of people who've been holding back waiting for the database to offer the features that they're used to, but at the new scale. So here we are with that. And then anyone who's writing apps in 2017 is going to want some kind of temporal features so that you can build streams and trigger events from changes in the database. So FaunaDB's data model keeps the old versions of records around for a configurable amount of time and allows you to take any query and put it into an event mode where you can see the changes that have happened to that query over time. So the next slide is really about what makes Fauna different. And this first point here, the object level security, is what we'll talk about in this talk because it's what you interact with as an application developer. It allows you to model your business rules in the database, and that goes hand in hand with the transactional support and the strong consistency, because as soon as you start putting your business rules in the database, you're going to ask it to not be eventually consistent, but rather to know which rules it's applying. This next point about the provisioning trap goes toward the business model or the payment model for FaunaDB in the cloud. So FaunaDB serverless cloud works by purchase points. Points are roughly 1,000 points for a penny, and they correspond to roughly a CRUD operation. Complex queries require more points. There's a point cost per gigabyte month stored, and the costs are comparable to the competition when you look at them in aggregate. So the difference, though, between the competition and the way that FaunaDB's pricing works is that you just pay for the requests that you make. So The client is living, wherever your application code runs, and it connects and makes a query when it needs to, and that's what you get billed for. You don't have to have provisioning for an ongoing amount of traffic that you have to predict in advance. You pay for the requests that you make and for the data that you store. So this means that your experimental app can bump along in the free plan for months, and then when it goes viral by surprise, we'll be there for you. The third point here, hierarchical multi-tenancy, I brought that up earlier, but what it's really useful for is having lambdas that provision new business realms, whatever your domain model is. So let's say you were building an app for hotel booking and you signed up a new customer. You might want to have some code that runs and provisions a database for each of the hotels in their hotel chain. And because the multi-tenancy is hierarchical, those can all run underneath your customer's hierarchy tenancy root and be subjected to the same quality of service and security provisions. So as the customer grows and pays more, the database will keep up with them in aggregate. Or if they have a special event going on at one of their locations and they need increased performance for that event for that particular time period, then you can turn the quality of service up just for that database. And this last point is kind of a subtle one, but really important. I see a lot of questions online about people trying to connect to their database from lambdas and having to deal with, like, is this lambda hot or cold? What is my relation to setting up a connection pool? And the FaunaDB client is stateless. It's just HTTP. So your lambdas aren't pay and setup and tear down costs. You don't have to think about that. You just construct the client based on the connection secret information that you have and start making your requests. So now that you know a little bit more about how FaunaDB fits into serverless, we could talk about the application architecture. So there are three main components to the application that we're going to be looking at. And I'll talk through these one at a time, and we will go and look into them in more details. But this content service is the main application code. It's the part that knows about to-dos and lists and your domain model. So in another app, it might be the users or the recipes or the forum posts. The content service is essentially the part that used to live in your Rails directory back in the day, and so that runs independently from this authentication service. They're both deployed with their own serverless deploy command and have their own deployment lifecycle and their own code bases. And the authentication service can authenticate users to multiple content services, and potentially the content service could accept authentications coming from different authentication services as well. But the point of the authentication service is that it's somewhat standardized. It does the OAuth dance so that your users can log in with Facebook or GitHub or Twitter or LinkedIn, or add custom ones. And the way that it works is we'll actually walk through all the details of how it works, but at the end of the day, it sets an authorization header that the API gateway can use to tell the content service how to connect to the database. And there's this third little piece that I like to call out because it's part of the authentication service's code and gets deployed with the authentication service, but at runtime, it runs with the content service. And that's this custom authorizer. It's essentially a function that gets deployed into API gateway that knows how to parse the authorization header that we set so that the content service can connect to FaunaDB using it. So I just want to say thanks for the questions that are coming in. We'll definitely have time at the end to go through and address all that stuff. So the last component to the application architecture is this front end, which I talked a little bit about before, but it does all the session glue. It sends the user to the right place to log in and stores the authorization cookie in local storage, and kind of manages that glue. So without the front end gluing things together, this becomes difficult to debug because you have to keep track of all those headers and sort of the application state. So in the content service, and we'll get into the code in a second here, but I want to go through and read you what the pieces of code we're going to look at. So we're going to look at how a to-do item is created, and we'll get to see the actual Fauna query that creates the to-do item. We'll look at how you can read all the to-dos and how the security model makes it so I only see my to-dos. We'll look at updating an object, and so parsing some JSON and updating the title, and then also how to toggle multiple objects, so to run a query that updates multiple different objects. So now we can go and jump into the code and just take a look at some of those queries. So here is the first one I said we'd look at. This is JavaScript that runs inside Amazon Lambda. There's very little that's specific to Amazon Lambda. This will also run inside other JavaScript function as a service providers runtimes pretty well. I mean, you'll end up wrapping the function signature differently. But what's key about this code is that we are loading all the to-dos and essentially going into this index, getting all the to-dos, looping over it, and fetching the actual to-do object from the reference. So what's notable about this code is that there's nothing here that makes it so you only see my to-dos. Yet at the end of the day, you only see your own to-dos. So the access control policy is being applied as we're loading these objects, and you're only able to load the objects that you can see. How the client knows which user it is, I'll get to that in a minute here, so we can be comfortable with that being a mystery for now. So you ask for all the to-dos, and you get just your to-dos in this case. Here we're going to create a to-do, and you'll have a better sense of how it knows whose is whose. So the data for the to-do comes off the wire by being parsed out of JSON, and that's just going to have a field completed, false, and title, take out the trash. Then what we do after we parse it is we create an object that we're going to send to the database as a query. And this becomes interesting code. So the clients are actually query builders, and this line of code isn't going to the database at all. It's just building a query fragment that resolves to the current user. So this at runtime just creates a query fragment. It's it's not going over the wire. It's completely synchronous, and we're going to reuse that query fragment in a few other places. So the data has the title and whether or not the item is completed, and now it also has a reference to the owning user. But that's just the data envelope. That's completely application stuff. Fauna doesn't look inside of there, except for indexing. But Fauna does have a native concept of permissions. So we're able to add permissions on this to-do item that we're creating that say that the current user is the only one who can do the reading and writing. And those permissions then will get picked up and reused throughout the application as we're running our other queries. When we go to load an item, we can just naively load it by the ID that was passed in via the HTTP event. And it'll only actually find the item if the access control allows us to see it. Otherwise, we'll get a security error. Here's the query for updating an item. And you can see, again, that we're finding the item the same way we did when we were just loading it before by its ID here. And we're just passing in the completed and the title fields that came in off the wire. So once again, all that access control is taken care of for us. So we'll jump back here and talk more about how that works. This is the status quo. Like what I did was kind of found how people in the serverless world were doing things, and then thought about how to make it better. So you've got the web app, which connects via the API gateway to the content service and the user service and the authorizer, and you can see the user service and the content service are completely independent. But what we've moved to in this demo is the database integration pattern that is was so popular back when databases still had features. So now we've got that again. The FaunaDB knows about both the users and the content and is able to manage relations between them. So I mentioned earlier serverless authentication boilerplate. That's the code that we didn't get into yet that manages the actual login and setting your user ID. And so if you go and follow the instructions in the README for this project, you'll be set up with this authentication system that allows you to log into your apps and with almost no work. So you're about to know more about it than you need to, unless you're going to use it. So you're one step closer to using that serverless authentication boilerplate. This is a sequence diagram of how the browser authenticates via this stack, and then how, once it's authenticated, the authorized requests are sent to the database. So first we'll look at authentication. What happens is the browser makes a request to a sign-in lambda, so that's its own function deployed under an endpoint and API gateway. And the sign-in function knows a little bit of config, enough to know something like, oh, this app is one that wants to let the user choose between Facebook and GitHub for login. This user chose Facebook, so redirect to the Facebook endpoint. Okay, so now Facebook, maybe you already approved that login and it just redirects you back immediately, or maybe you have to deal with some Facebook UI as the user. But either way, the Facebook, once you're done with it and you've approved your login, redirects you to another lambda that's inside the authentication boilerplate, which is this callback service. The callback lambda, now it knows your Facebook ID, and so it can find or create a user in FaunaDB based on your Facebook identity. And once it has that FaunaDB user, then it asks FaunaDB for a login token, a database secret that corresponds to that user. So the callback function sets an authorization header and returns that to the browser. And now the browser has this authorization header that when you use it, it does two things for you. One is it gets you through the API gateway, and two, it lets FaunaDB behave as the current user. So that's what this looks like. In the course of regular application use, you're already logged in, and the browser is going to make an API request, say, to read all my to-dos, or create a to-do, or whatever. And on the way to the content service, the authorizer actually kind of acts as a proxy. The authorizer unpacks that authorization header and turns it into an API gateway policy that attaches a FaunaDB secret to it. So now the content service knows who you are and can talk to the database as you. So that's this connection over to FaunaDB. The content service is loading to-dos, modifying to-dos, running those queries we saw, all in the context of the current user, and then sending that response back to the browser. Now, there's one detail in these flows that needs to be accounted for, and that's this refresh loop, which is what happens when your session expires. So the browser goes to the content service, and the content service goes to the authorizer, and the authorizer says, wait, that cookie is expired, or that token is no longer valid, and you get an access denied, which the content service returns to the browser. And so again, this application integration code, the stuff in TodoMVC, has to catch that error, and the way that it's written is it just assumes these access denied errors can be resolved by trying the refresh token that it has on hand. So the refresh token goes to this other Lambda function running inside of the serverless authentication boilerplate service, this refresh function that's not behind an authorizer. The refresh function you connect directly to, and you give it a refresh token that was attached as part of the payload early on in the sign-in flow. The refresh function goes and finds the user that corresponds to that token and creates a new database secret for that user, which gets attached to a new authorization header and gives you back your session. So you're back in the game again, making API requests against the content service and creating to-do lists and all that stuff. So now we are to the point where we're ready for a demo, and I'll just go show you this app real quick. You can also go to the URL yourself if you want to try signing in. It looks like this. I'm already logged in, so I can say, take questions in webcast and create that item. And let it work its way over the network. There we go. So I'm currently logged in as me. If I log out, I won't see anything, and if I were to log in with someone else, I would see a different set of to-do lists. The application is pretty simple. I'm currently doing work on a version that supports multiple to-do lists and the single-page application style. And eventually the plan is to have those lists shareable among multiple users to fully demonstrate the social and security features of FaunaDB. So while we're over here in the browser, I guess maybe it makes sense to do just a tiny bit of homework so you can see what it would take to get started. So I went to fauna.com/signup, and I put in my email address, and if I click this link, it's provisioning me a database, and it's going to redirect me all the way over to the dashboard where I can use the database. So if you did what I did now, you have your own FaunaDB account, you have your data, you have an email to confirm and set up a password and all that sitting in your inbox, and you can follow these instructions to create a database and put data in there. It's pretty easy to get started, create instances. And so now we've got some data in our database. Of course, there's plenty of advanced features that you'll want to get to. So let's come back to the slide deck, and we're almost ready to go to Q&A. I know I've got some good questions in there, but if you've got any other questions, now's a good time to drop them in. I guess here's like one of the advanced topics that was front of mind for me when I was writing this code at first, is that there's two different ways to manage your schema, and I think they're both right. So in instances where you have already configured your your cloud runtime, your Lambda functions, the things that live in your deployed security envelope, with a privileged secret to FaunaDB, then you can have a Lambda that lives in your service that's just like creates schema and is not tied into API gateway, and so you just invoke it from the command line, and it runs in the cloud and manages your schema or any kind of migrations you might need to do. But I realized in the course of writing this that, well, first of all, that serverless CRUD application service, the content service, doesn't have a privileged secret to the database. It doesn't have any way to connect to the database until a user logs in. So doing all my schema work and my admin work from my workstation actually just made a lot of sense. And so I think that's just a lesson about the flexibility of the cloud. It's great when there's more than one way to do things. So these are the links that I talked about. If you go to fauna.com, you can sign up. If you go to the GitHub for Fauna, you can find serverless CRUD, you can find TodoMVC, and you can find links in those READMEs to the authentication boilerplate. There's also a blog post on serverless.com that goes into detail about setting this up. So yeah, enjoy those links, and let's see what we've got for questions. So the first question is about how we compare to Google BigQuery. And I think that maybe the biggest difference is that our sweet spot right now is the operational interactive database stuff. So BigQuery is more analytical. We have analytical indexes on our roadmap. And so over time, we'll be even more able to offer kind of graphs over time series data and all that. But for now, I think we're maybe more comparable to Google Spanner. The rest of the question goes on to ask where we're hosted and how the subscriptions work. And I didn't mention, but it's worth mentioning that and let's see, I think I have a slide for it. We have FaunaDB running in Amazon and Google clouds, and we're adding Azure so that you'll have low latency, low cost access to your data from within any of the cloud providers. And we're also working on a feature that allows you to pin your replication just to the locations that you need, so you don't have to pay for full replication if you don't need it, and can run only in the 3 data centers that you care about. So I hope that answers the question. So there's another question here about first serverless database, and the way that I like to think about that, the question goes on to say, like, well, there's all these other databases that people have been connecting to from serverless applications, and the way I think about it is that cloud databases enabled serverless to come about. You couldn't have, or it wouldn't do you much good to have managed runtimes for JavaScript functions, for function as a service, if you didn't have a cloud to store it in. So you needed to have these cloud DBs to enable serverless, but they were all around before serverless. They weren't really built for it. They weren't really built to answer the same requirements. So a lot of them are quite close, but there's a little bit of impedance mismatch, specifically around the pricing, where you either need to set up some kind of auto scale system, or you're going to end up throttled by your provider or paying for capacity that you don't need. And then, even with the auto scale, the matching capacity to usage is only loose, and you have to think about the difference between peak and average workloads, and all this stuff that really, when you're dealing with those, when you're even just thinking those kind of provisioning type thoughts, it's taking you out of the serverless realm. The last question is about my use of the word lambda. Yeah, I mean, Amazon's function as a service, that's what I've been using here, but this is also, I've done Hello Worlds on Azure's function as a service, and OpenWhisk is a great fit too. So I mean lambda both in the specific and in the generic sense. So are there any other questions? Thanks everyone for joining. The recording will be available, and if you're interested in this stuff, there are a couple of blog posts. Actually, let me just bring up the one blog post that I think may be relevant. It's regarding single-page applications. So this is where you want to go if you want to see a version of the app that we did today that has a little bit of a deeper security model, in the sense that it has, let's see if I have an account on this instance. Yeah, so it has more than one list that you're allowed to drill into and manage, and each user has different sets of lists. So FaunaDB.neocities.org is running a slightly more advanced version of the TodoMVC application that is a single-page app and does not use function as a service, essentially between the client browser and the database. So it's a good place to go see patterns for, user sign up directly to the database without any kind of service sitting in between the user and the database. So there's a question about compared to DynamoDB, what makes it serverless? And again, what I mentioned earlier about the provisioning model, DynamoDB is, it was a great enabler of serverless because, it allows people to, store and retrieve their data and run simple queries without, worrying about where the servers run. But you still got to worry about how much traffic you're going to have, and if you get that wrong, the consequences can, be either expensive or embarrassing. So I think that, as long as you're operating a database, it's not really serverless. Well, thanks everybody for coming out. I think that's it for me today. Thank you.